So today we are going to be working on 2.7. So they're just word problems. They're applications of what we've been doing with equations here. So here are some notes just on how to solve word problems there at the top of your note sheet that you have out that you're taking notes on. Read the problem, determine what it's asking you to find, assign a variable to the quantity that you're trying to find. So usually using the variable x, or some people like to use whatever we're trying to represent, they might use the first letter of that. So if you're doing candy, or they might represent with a C, or if you're doing the number of hot dogs, you might represent that with H. It's up to you. So then 3, write down what the variable represents. 4, reread the problem and write an equation for the quantities given in the problem. 5, solve the equation, and then make sure you go back up for number 6 there and answer the question of the problem, because sometimes you have x equals, what does that mean? And then check your solution. So example 1 here says write an equation for each problem and then solve. So 2 buses leave Houston at the same time and travel in opposite directions. One bus averages 55 per hour and the other bus averages 45 miles per hour. When will they be 400 miles apart? So we need to go ahead and set up an equation here to represent our variables here. So let's look at x here. I like to use x. So when it says when, we're talking about time. And our time in the problem has to do with hours. So I'm going to say x here is the number of hours, or the time each bus traveled. So they both travel the same amount of time. And then you've got to know that there's a nice formula that has to do with distance, rate, and time. It's called distance. It's the distance formula for this one. Distance equals rate times time. So you multiply your rate times your time there. So the abbreviation for that is D equals R times T. Now if you go up in the problem up here, you can see that we've got some rates going on here. Bus 1 averages 55 miles per hour. That's bus 1's rate there. So I'm going to go ahead and plug that into the formula here, that this is 55 miles per hour for bus 1 there. So 55 there, and then its time is x. And then the other bus here is, the other bus averages 45 miles per hour. And it says, when will they be 400 miles apart? So gonna have to add these two here together, because we want to get the distance that bus 1 here travels is right here at 55x. The distance that bus 2, or the other bus there, travels is 45x. And together they end up having to be 400 miles apart. So we can take distance times time plus distance times time, and it'll give us the total distance that the two of them there are apart, and we can solve that for x and find out how much time they traveled. So 55 plus 45x there gives us 100x, and then we can divide by 100 to get the x all by itself, and we end up getting x equals 4 hours. So when will they be 400 miles apart? I'm going to say x equals 4 hours. Notice I labeled my answer and everything, and I answered the question. All right, let's go on to problem number 2. Write an equation for each problem and then solve. So this one here, we've got 2 planes left an airport at noon. One flew east and the other flew west at twice the speed. After 3 hours, the planes were 2,700 miles apart. How fast was each plane flying? So kind of thinking through this very similarly, but not exactly the same. We've got 2 planes. They're leaving the airport at noon, and one flew east. The other there flew west at twice the speed. So I'm starting to think down here, and the question asks us how fast. So that's asking about speed or rate, same thing. So I'm still thinking in terms, and we've got some distance up here, this 2,700 miles there apart. It has to do with distance there, and then I got some time in here. It's 3 hours. So I'm thinking still we're using that nice formula, distance equals rate times time. But this time the question there asks how fast are we going? So this time we need to find some rate here. So I'm going to say x equals how fast the plane going east is going. So speed of plane flying east. And then it says the other flew twice the speed. So twice that would be 2x equals the speed of plane flying west. So now we've got the two speeds. And again, we're doing that distance equals rate times time formula there. So we've got, after 3 hours, the planes were 2,700 miles apart. So again, we can do that total distance of 2,700, just like we did in the last problem, is we took the speed of the plane flying east there and its time. So 3x, because you can do r times t here, the east plane. And it flew 3 hours, and then plus the rate times the time of the western plane. And the western plane here was 2x times 3. So we get 3x plus 6x. So really you get 2,700 equals 9x. And then we can just simply divide both sides here by 9. And we end up getting x equals 300. So the eastern plane there is going, we got miles up here, and we're talking about hours. So speed is miles per hour. And then the other one there, we can go ahead to find the other plane there, the 2x is equal to 300 times 2, which gives us 600 miles per hour, because the other one flew twice as fast, so I can take 2 times it. So there we've got the eastern plane speed, and we've got the western plane there. So we answered that question, how fast was each plane flying? So example 3, same type of questions here, but this time the length of a rectangle is 3 centimeters greater than its width. The perimeter is 24. What are the dimensions of the rectangle? So for one like this, I like to kind of draw a picture. And it says, here's my rectangle, and it says the length is 3 centimeters greater than its width. So I'm going to call this my width, and then the length here is 3 centimeters greater, so that means W plus 3. So I could say W equals my width. My length of my rectangle here is W plus 3. All right. So if you remember how to find the area of a rectangle, it is length times width, but this one here says perimeter. Perimeter is when you add up all the outsides here. So let's work with perimeter here, not area. So perimeter, you're going to add up all the outsides, so we can do that. We can go W plus 3 plus W plus W plus 3 plus W. And we already know what that perimeter is. Up there at the top, it says it's 24. So let's solve this. 1W plus 1W plus 1W plus 1W there is 4W. And then I've got this 3 plus this 3 here gives me 6 equals 24. And now I can just simply solve this. I can get rid of the 6. And I get 4W equals 18 there. And then we can continue to solve this and go ahead and divide both sides here by 4. And when I end up doing that, I'm just going to take 18 divided by 4 there, and I end up getting 4.5. So that's going to end up being my W there, my width. But remember, it says the dimensions there are in centimeters, so I'm going to label it centimeters. So now I'm going to go ahead and find my length is W plus 3, so I can take W and add 3 to it, and I get 7.5 centimeters. So my length and my width there, 4.5 centimeters, and it ends up being 7.5 centimeters. So we've got another one on geometry here left yet that I wanted to go through. The measure of the supplement of an angle is 20 degrees more than 3 times the measure of the original angle. Find the measure of the angles. So first of all, you got to kind of remember from geometry, supplementary angles add up to be 180 degrees. All right. So we've got 2 supplementary angles here. They kind of look like this, adding up to be 180 here. So the measure of a supplementary angle is 20 degrees more than 3 times the measure of the original angle there. So it's going to help us to set up the problem here. So we can go ahead and figure that out. It says, I'm going to say x equals one of the angle measurements, angle measure. The other one here, it says the measure of the supplement of an angle is 20 degrees more than 3 times the measure of the original angle. So if this is the original angle here, you can do 3x and then add 20 to it. That equals angle supplement. Measure. Alright, so together the 2 of them have to add up to be 180. So I could do that. I could do x plus 3x plus 20 equals 180. Combine my x's over here, so I get 1x plus 3x is 4x. I could subtract 20. I get 4x equals 160. Divide by 4, and x ends up being 40. So there's one, 40 degrees. The other one there is 3x plus 20. So I can do 3 times 40 plus 20 gives me 120 plus 20, and I get 140 degrees. So notice the 2 that I have boxed there, if I add them together, I do get 180 degrees there. So let's do one last one here. I think we got time for one more. If we don't, that's okay. Okay, so the next one says 4 consecutive odd integers. Odd integers would be like 1, 3, 5, 7, and when you add them all up, they're supposed to give us, some means adding all together, they're supposed to give us 184. Well, obviously those don't equal 184. So we got to think of ones that do. So I'm going to say x equals the first number